Okay, so that took a little longer than I thought it would do. All of these little buggers are very difficult to get out. Cut the hole front and back. See, I've already got one of the glands in place there. We'll just fit this second one, and then what I'm going to do is hot melt glue all of the components into position. I have screwed them before in the past, but sometimes all the screws poke out of the back and it can be quite a pain in the butt. So first things first, just reach down and get the other STC 1000 controller, because I've already fitted one of them in the other unit. A little dry run, make sure everything fits before we started the camera rolling. So I slide these little beauties off, if they'll come off. These are the retaining clips. There's always that back bit there. There we go. Get rid of the box. So making sure it's installed the correct way up, we'll pop these retaining clips back in. Easier said than done, it would appear. There we are. And then next I'm just going to dry fit all of the other components. I should have got them all out ready, shouldn't I? So yeah, I've already looked at this. That wants to go that way with the yellow tab down. It seems to be the best, because then you can get to these main relay contacts, because they're pretty much going to be the first ones that we're going to install. And then we've got the power supply unit. So what I thought I'd do also was spin it around. So this is the 240 side. You can tell because you've got the rectifying bridge there. So we'll pop that to that side, and then all of this side is 12 volt, you see, and they're going straight out, so we're not crossing the 12 volt wires across the 240 too much. And then these two, that probably wants to come out. In all reality, to be fair, I'll show you how difficult they can be, or easy, however the case may be. Well, that's proved me a liar, hasn't it? So we pop them there like that, and that, I think that is a good looking board. So just get myself some hot melt glue. Put that one there. That one there. Oh, these were the trickiest. Should got to get them down before the glue starts to cool. And the same with this one. There we are. So what we're going to do with these buzz bars is just get some wire, and we're going to just bridge all the terminals as and when needed, both sides. So we're basically putting little jumper cables in there. Makes it simple, nice and simple. And then Same for this DC power supply module. There we go. And then, fingers crossed, everything's in place. That looks pretty good. I'm quite impressed with that. Yeah, that's pretty good. Okay, so I think the next job is we'll get some jumper cables in here first, because they're the trickiest things to do. And then we'll start to wire it up, guys. So I'll be back in a tick. Right, that's all of the neutral buzz bar complete. So now I'm just going to finish off with the live buzz bar. There we go. Can be quite tricky to get some of these in initially. Shall we go this way? It might be easier to go this way. The blue cable that I used wasn't exactly as stiff as this wire, so it was a little bit more difficult to get them to go where I wanted. But these are very well formed little jumper cables, to be fair, in this brown 2.5mm cable. If that's the right word for it. Is it cable? I can't. It's strange when the camera comes on, sometimes you can just go blank on the most simple words. Right, I'll just use this electrical screwdriver to coax them in. They should all fit in there quite nicely. I've wound the screws out far enough, I believe. So let's give them a bit of a poke. There we go. So if we start from one end, tighten them down. So this means if you put power to one end of this circuit block, then every single outlet on it will be able to receive that power also. This is the problem child here, look. What's his beef? Ah, there we go. Seemed like it was just caught on the screw. Yeah, so effectively it's a poor man's buzz bar. I would prefer to use a solid block of copper or something like that, but all these things are built on a budget. And it don't stretch that far. And it's 2.5mm cable, it's jumping not far at all. It's more than capable of coping with the load that we're going to be putting on it. And it's not going to be exceeding 10 amps, I don't think. So there we go, what do you think to that? Hold it up. Yeah, the live buzz bar is definitely a lot neater than the neutral, but they're all tucked in there nicely. Nice little bit of separation between the two as well. That looks about as neat as I've done it, if I'm honest. Right, the next thing I'm going to run is a live and neutral feed from one of these buzz bars across to the AC in on this little transformer. So looking at the cap that I took off earlier on, we can see that we've got live, neutral and earth. Not that I imagine the live and neutral makes much difference. It is AC after all. So we'll wind them all out. So first things first, if we figure out what path we're going to take, so we may come out of that one. Seems nice and close. We'll come down there and do a 90-degree turn and go straight into him. So let's cut that and let's shape it. So first thing, put a nice 90 on that bit there, and then that's almost doing a U bend. It's almost doing a U-ey. So we'll put a little U-ey on him so he can go in there, and then he's running straight across to about there. And then we'll put a nice tight bend on it there. Right, I think we just need to trim that edge off a little so he sits in there. Yeah, maybe that bend needs to just go back a little bit. Maybe there. Oh, beautiful. And it is the live port. So we'll just strip her back using these phyllo strippers. These were quite expensive little wire strippers, but I must say they work a treat. You can set the depth on them and everything. They really are quite nifty. Alright, let's put that bend back on. So we'll hook him in there. Aha, I see where I've gone wrong. I needed to shorten that cable to about there. Let's take him back again. Right, let's try him now. That is just looking fantastic. We'll pop that into the live terminal, and she sits in there very nicely indeed. We'll tighten her up. And there we go. That's the first wire in. So I'm going to continue to do that. I'll do the neutral to the DC terminals, at the AC terminals on this DC converter as well. I'll put power into the STC 1000. I'm going to run power into the cooling bank, the terminal 7 on the STC, pin 7 on the STC. I'm also going to take neutral out of pin 8, I believe, on both of these relays, and run that into the neutral bus as well. And anything else I can think of, power to the STC, I did say that already. Of course, if you was using the heating side, you'd have a relay for the heating, another one of these. You probably need a bigger box actually, and you'd bring off a live feed through terminal 5 out of terminal 6 to terminal 7 of a relay, and then terminal 8 would be a feed back to the neutral bus. It's basically the same for all of these. Live out through the relay on the heating or cooling, and then back out to pin 7 on the relays, and then neutral comes out of that then because it's been used, and back into the neutral bus. For these two, they're both running off cooling, so pin 8 is going to come out and it's going to be a split cable, one going either direction. But you'll see that when we come back. Right, then we're back momentarily, just so I can show you all of these terminals that have been connected. So we have the neutral bus going to pins 8 on both of the relays. I've just taken that relay out. Basically the relay sockets, if you like, but you know what I mean. We've got power going into the DC converter now, AC to DC 12 volts, the voltage dropper, whatever you want to call it. We've got power coming in to the STC 1000. We've got power going in to the cold side of the cooling relay, and then on the outlet the cable is split into two. One side goes to pin 7 on that relay, and the other side goes to pin 7 on that relay. So the only thing that we have to add now is the output from the DC transformer around and into the valve relay, and then one more live feed into pin 6 of the pump relay. So that just happens to be on this side, whereas in my sketch I've got 6 over here, but it's over that side. Now you may notice that I could, you may think, just use one relay. Look at that, I'm only using one side of each relay. Well, unfortunately the difference is that if your motorised valve is not doesn't have 3 lines out like this one, then you need to do the old switcheroo on the cables. So you'll have your DC positive, negative on 5 and 6 respectively, and then what you will do, let's say you've got your positive on line 6 on pin 6, then in order to reverse the polarity, you'll have on the normally closed side, you'll have the positive from the valve, the red cable, and then you will also have the red cable on pin 3, and then the black on 1 and the black on 4, and then just tie them up together this end. So if the normally closed pins are activated, there's no power to the relay, then it's just like having it wired directly to the transformer, the 12 volt transformer, and it will close the valve. If the relay is actuated and the normally open contacts are now closed, then it's going to switch the polarity for you. So you're then going to have the reverse voltage going through the unit, and the valve will open. I'm sure I'm making it sound more complicated than it really is, folks, but all will be revealed. Okay folks, you'll be able to see now that we've pretty much got everything wired up, and there are also a couple of extra cables in here. So these 2 cables that I've pulled out here are actually replicating the glycol pump. So we've just got a neutral going down to the negative rail there, and live coming out of terminal 6, and then across here I've just wired it up, taken the plug off a lamp, wired it up to the lamp. That's going to be our glycol pump for this little experiment. And then also I brought in this little quick test meter. This is another big Clive.com special as well, so this enables you to just plug things in and test them on the fly without having to wire up a whole plug on everything that you're experimenting with. So what I'm going to do is just shut this down now. So now all of this is live, and we're just going to take a little peek at the front. You can see it's reading 22.1 degrees in here. I've set it for 24 or 25. So while we're waiting for that to get over it has a 1 minute timer delay, and that's the lowest you can set it. So while we're waiting for that to complete, what I will do is just wire up the motorised valve. And I did notice that it's open if you put the positive connection to the red wire. So there we go. That's just going to close for a moment. So that's closed because as far as this unit thinks now, we're at temperature. We're at 22.1 degrees. You can't see it, but we are. So what we'll do then now is pick up the probe, the thermo probe, and then what should happen when I hold on to this is the STC 1000 should increase in temperature. It will call for cooling, hence turning on the motorised valve, opening the valve, and at the same time turning the simulated glycol pump on. Right, so I'm holding that in my hand now. You can see the temperature is beginning to increase. Here we go, 24. So the valve's closed, the light's not come on. Maybe it'd help if the lamp was turned on at the other end. Anti-climax there, that's live filming for you. So now if I just hold on to this probe, blow it, let it cool down, maybe I'll dip it in my beer. 29, 27, 26. Yeah, my beer's pretty warm. There we go. Everything back off. And the valve's closed. Therefore, no glycol can go into the machine. The glycol pump's turned off. Everything seems to be working okay. So I'm happy with that, folks. It's not as complicated as it looks, it really isn't. I'll just get the power out of this. Just open that quick test. Yep, I'm quite happy with that. So I'll just disconnect these test cables. They can come back out. So when you connect that up, that's where your power would go in. Basically a plug socket, if you like. And then your negative, or your negative from your pump will come into your bus bar, and your positive for your pump will go through the pump relay. And there we go. That's all there is to it, folks. It's relatively simple, wouldn't you say? Right then, guys, I've got another one of these to put together or finish off. So while I do that, I'd appreciate it if you left me a comment, ask any questions on this. I'm going to upload this onto the website idlevalleybrewing.com. I'll put a particular page up for it, and I'll leave a link down in the description. So if you want to build your own at any time, all the info is going to be there. You'll be able to watch the video I've put it together. It really is a piece of cake, and you can pretty much control anything with one of these. If you want to keep it hot, cold, perfect little piece of kit.